Hey everybody, just wanted to go over question number 21.17 and getting into the fun stuff where we're talking about decay series happening, where you go from uranium 92 to, uranium 235 to lead 207. This is kind of interesting because this is actually what happens when uranium naturally decays radioactively. And so what we have is uranium 92 235. It undergoes a series of alpha and beta emissions. Okay, so I'm going to write something here, alpha 4,2, and then beta 0, -1. Okay. And that's going to give us also, let's see, plus. That's also going to give us lead 207. PB, let's see, 207, and then 82. So here's the interesting thing is when we do this, we're trying to figure out how many of each type there are. Well, there's only one type here. Let me change my color. Okay, there's only one type here that affects the mass number. We want the mass number to go down to 207. That has to happen by alpha emission. So when we look at this, the difference between 235 and 207 appears to be about 28. And I don't even want to say about, it is 28, okay? And so that means in order for uranium 235 to turn into lead 207, has to undergo 7 alpha emissions, okay? So that's the first step in doing this. Now we have 7, we know it has to be 7 alpha emissions. But now the bottoms all have to add up. So this is, and I'll do that in green here. So this is 92 has to equal, let's see, this is 14 plus something plus 82. Well, 14 plus 82 is 96. So this has to be 4 less. Somehow these two have to equal each other. So this has to be 4 less. So this coefficient has to be a 4. It's the only way you're going to get that equal to each other. And this is true. Now, we're not implying what order the alpha particle, alpha emission or beta emission happens. Okay. But we know that in order for uranium 235, radioactive isotope, to turn into lead 207, it has to undergo 7 alpha emissions and 4 beta emissions in order to do that. Okay, so that is question 2117, and I hope that clears this up. Okay, see you later.